So picking up where we left off, we previously imported movie data that came in here as import job 1. We can now run motion correction on the imported movie data. Again, we're not actually running motion correction, but instead we are pulling results from a database, but it's as if we are running motion correction. So motion correction is the next job down here on the list of rely on jobs. If you click on motion correction, you see there's different options to provide. The first option is what data are you going to run it on. And in this case, remember, green input boxes and choices are what we interact with the simulator, whereas magenta, we don't need to touch. So in this example, it wants to know what movie data. So if you click Browse, you'll see that Reline will populate input files that are relevant for the given job. So in this case, we are running motion correction, so the data needs to be movies. And so here, if I look at the import job, there's only one job, job 1, and this is movie data, which is captured in this file called movies.star. So movies.star is a text file that is pointing to the actual movie files, and that's how Relion knows how to find the files. There are options in here that we're not going to touch nor we're going to cover at this point in our tutorial, but leave these constant. The next tab, the way Relion works, we have an input-output tab typically, and then there's a motion tab. This example, we can have different options here related to motion correction. And so we're not going to review a few of these options, but the typical options that you will change would be the number of patches. So this will be dividing the movie into a series of patches that you'll use to align locally to give you local correction of motion, and then we'll have 25 patches in this movie. We're going to group the frames by 1, and then the binning factor is 2. And so grouping frames refers to averaging certain frames together during motion correction, which typically we don't need to do. And then the binning factor is important if you have super resolution data so that you can scale it down. So in this case, our input data are at 0.455 angstroms per pixel in super resolution mode. And so now it's a good time to bring it back to fit the real physical pixel size of 0.91 for the sake of storage and speed, because we're not going to be getting any information past the up near 1 angstrom in this data set. The input options you have to choose right now are whether or not you will use a gain reference image. And so let's say you want to use a gain reference image, we can find it here. And so what is a gain reference? This is the image of the detector that we want to remove from our micrograph. So you can think of it as, it's also called a bright field image, where there are patterns on detectors that you don't want to see when we start analyzing data, and that the patterns will give incorrect intensity changes to particles that might mess up alignment steps later. So we try to correct for it. So let's input the gain reference image. This is this file here that we already had copied. It's MRC formatted like this. So we click OK. We have the choice of rotating or flipping the gain reference. We're going to leave it as this option for now, but you as the user could change this to see what the outcome is. So after this, we are now ready to go. In the running tab in sort of real life, you would have to change parameters here. For us, this doesn't matter. We are just here to run motion, to simulate motion correction. So when this is all set up, we can click run. Just like other jobs, what you'll see is the back end on the terminal, our simulator is looking through our pre-calculated result database to find the job that corresponds to these parameters. So you're sort of sifting through informations. Eventually, when it finds the right one, it'll come back and you'll see a finished job show up, like here. So in this case, motion core job 3 has been populated. Down below, there's this output text. This is called the standard out for Relion, or the output. And if you double click it, it'll show you the full output. In this case, there isn't a lot of information. It tells you the movies it found, then it tells you that it ran motion correction, and then it also generated a log file. Finally, it outputs micrographs.star. We can look at this a little bit further. So if you are looking at a finished job like this, if I click motion core, there is this display pull-down menu. And it shows me two things. It shows me the star file of micrographs, and it also gives me a log output file in PDF format. So if I click on the PDF file, I'll be able to look at different information about the jobs. Let's go back to the top here. So there'll be a few different parameters that's going to report to you that you could consider when you look at different data sets. So here it's showing you what's called accumulated motion totals. This is the total motion in a micrograph that it measured during motion correction. This is just per micrograph here. So the first movie had the most motion, whereas the other movies had less motion. And this index is just the micrograph index number. The next plot is a histogram of this total accumulated motion. Again, you see this one image. It's one movie is more of an outlier. There's another option, another parameter it looks at, which is the early motion. Again, indexed across micrographs, then a histogram. And again, you see that this first movie had more. And if we go down a little bit further, this is now what they called late motion, which again, clearly this first movie had more motion the whole time, whereas the other ones were more close together. And then finally, just to show you what it did, it will plot every movie a few different things. So here it's showing you X and Y for a given movie. This is a super resolution movie, which is why it goes 0 to around 7,000 pixels. The first line in blue is the total average motion of the movie, of the global frame alignment of the whole movie. Then what you have in gray are individual patches of motion. And you can see the gray patterns are noisy. And so the trick with patch-based motion correction is they are trying to balance information from the global alignment with local alignment. And so at one extreme, every trajectory is exactly the same as the global, which means you didn't really do any local motion. At the other extreme is you are just focusing on single particles moving through, let's say, a movie, which is very noisy and hard to be confident in the tracing. And so what these programs will do is some kind of combination of weighting local neighbors and the global to give you a more accurate patch-based motion. And you can look at this for every frame. And you can obviously tell this first frame had the most motion, total motion in this blue line, and also in these gray lines compared to subsequent movies. Okay, so we can also, that's the output from motion correction. Great, so we can close this here. And now we are ready to move on to the next job, which will be CTF estimation.